This is analog and digital communication systems. The paper code is EC501. Total number of contact hour is 36. The contact per week is 3 lectures, and the credit is also 3. Myself, Dr. Indranath Sarkar, Associate Professor, Department of Electronics and Communication Engineering at JS College of Engineering. Welcome to Analog and Digital Communication. This is Module 5, Digital Modulation Techniques. There are 5 course outcomes of this subject. The first one deals with, it explains the importance of analog and digital communication. That is the modulation and demodulation schemes. In this case, we are very much interested to grow the knowledge of the student towards the basic definitions of the modulation and demodulation part. The second course outcome deals with the analyze analog communication system for their signal to noise ratio, efficiency and bandwidth, because whenever students are dealing with the signals, they are very much interested to know about its power that can dominate the noise over the channel. So that is why signal to noise ratio plays important role for analog and digital communication, as well as its efficiency and bandwidth. When the signal is received by the receiver, the accuracy should be as high as possible. The third course outcome statements is to compare the advantage of various pulse modulation technique and analyze their system performances. And the fourth one deals with demonstrating signal representation. So this is one of the most important part of the course, that is how to represent the signal or signal constellation, because once the signal position is known, therefore we can describe the noise margin or noise cloud around the signal vector tip, so that the amount of noise that can contaminate the signal will have a prediction. So that is one way to check the communication system suitable for a certain area. Analyze various digital communication techniques, can compute the bit error performance and compare their advantages and limitations. So this is the last outcome, which is dealing with the efficiency of the digital communication system, in which the bit error rate as well as several types of error cases, that is type 1, type 2 errors, will be discussed here, so that students will be able to demonstrate such factors. There are 5 modules in this subject. The module 1 deals with the introduction, where the introductory concept of the communication system will be discussed, and thereafter the basic knowledge of the analog communication and digital communication and their correlation, that is interdependency of those two communication system over the timeline. And the second module deals with the random processes. The random process it deals with certain mathematical examples as well as principles, in which the statistical characterization of the signal will be analyzed. And the module 3 deals with the pulse modulation. The pulse modulation basically analog communication technique, and it is also the bridge between the analog and digital communication technique, because the pulse modulation produces pulses corresponding to instantaneous magnitude of the analog signal. Several categories of pulse modulation are also to be discussed in this module. And thereafter the module 4, which is signal vector representation. So if signal vector is properly represented, then we can predict the amount of noise that can contaminate a particular signal, whether the signal will withstand with respect to that noise or not. So all these things could be predicted. Digital modulation techniques will be discussed here, and differential pulse mode modulation to shift keying techniques, all these things will be discussed in the last module. The prerequisites of this analog and digital communication is the knowledge of signal vector representation, characteristics and of additive white Gaussian noise, geometric representation of signals, synthesizer and analyzer, signal vector, signal space, Euclidean space, etc. And this is the corresponding COPO mapping for the analog and digital communication. There are 5 course outcome statements which are related to the program outcome vertical with 3 different weightages. The first one is the highest weightage, numerically 3, medium weightage is 2, and the lowest weightage is 1. So why it is 3 given? Because program outcome 1, 2, 3 are the corresponding knowledges of engineering, as well as program outcome 10 and 11 deals with the communication and project management and finance. So in this case we are giving higher weightage to each of these course outcome mostly, and there is a low weightage are getting program outcome 5 and 6 because it is the theoretical subject in which the modern tool uses and engineer and society impact are less, and almost environment and sustainability, ethics, these are coming less to this subject. So depending on that, this COPO mapping has been introduced. The course objective of this analog and digital communication is to familiarize students with the fundamental of analog and digital communication systems, to provide students with tools for communication signal analysis, to familiarize students with various techniques for amplitude modulation and demodulation of analog signals, to develop the students' ability to determine the effects of receiver frequency and phase errors in synchronous modulation systems, to familiarize students with techniques for generating and demodulating narrow band and wide band frequency and phase modulated signals, to familiarize students with basic techniques for generating and demodulating pulse code modulated signals, to familiarize. The topics to be discussed are the quadrature modulation, Gaussian minimum shift keying technique, differential, the difference between the quadrature phase shift keying and the GMSK, the GMSK signal dependency, the Gaussian minimum shift keying modulator, demodulator, and the spectral density. The quadrature modulation is one of the robust modulation technique in which the occupied bandwidth can be reduced by converting the data to 2 slower streams and impressing each stream on the sine and cosine of carrier. For example, quadrature phase shift keying is performed in the form as shown in the block diagram. Now if we see that the rectangular path train which is applied to the serial or parallel converter, they segregates the even bits and the odd bits in 2 parallel paths. If we see the even bits which are traveling towards the top multiplier, the top multiplier is fed with cosine omega ct, and the bottom one, which is the odd bits segregated, are applied to the multiplier where another carrier is sine omega ct. Now since the carrier signals are out of 90 degree out of phase, they are called, one line is the in phase line, another one is quadrature line. In general, the top line is known as the in phase line and the bottom one is known as the quadrature line. So in this way, whatever signals we are getting, they are fed to the adder, and that adder produces the resulting modulated signal. If we see carefully, here we are getting that 180 degree phase shift is occurring, somewhere there is a transition between 0 to 1 or 1 to 0, still 90-degree phase shift is also occurring. So this is the quadrature phase shift keying, is the quadrature modulation technique. Now in this case, sometimes the clock frequency is also having some additional circuitry, so that the even bit and odd bit could be separated. So therefore serial to parallel converter is a block of circuit in which the clock is specially treated through a circuit, so that it is able to differentiate about the even bit and odd bit. Because there is a toggle flip-flop, toggle flip-flop is having complementary clocks. That means one path we are getting rectangular clock pulses, another path we are getting complements of those clock pulses. That means when one bit is 0, another bit is 1, and when one bit is 1, another bit is 0. So here Gaussian minimum shift keying is represented from the frequency shift keying signal. That is, frequency shift keying signal occupies larger bandwidth, as we have seen in case of frequency modulation in analog communication. Frequency modulation has multiple sidebands, and that is why the bandwidth of frequency modulated signal is very large. But still, though the bandwidth is large, frequency modulation technique is always robust in nature. Similarly, in case of frequency shift keying, we are utilizing two different carrier frequency for logic 0 and logic 1, and here in this case also we are getting more bandwidth requirement in case of frequency shift keying modulation technique. Though it is not contaminated on magnitude, that is why it is robust, but still there is a larger bandwidth is one of the great limitation in terms of the expenses of the system, because the service provider has to spend more, and the consumer also has to spend more compared to the other system. So therefore frequency shift keying technique has one disadvantage in terms of cost, but in terms of noise it is a truly robust system, because in this case, if there is an amplitude fluctuation which is incorporated by the channel, that may be removed by means of introduction of some limiter circuits or clipper circuits, that may remove the additive noise introduced into the frequency shift keying signal. So shaping the bandpass baseband signal is also one way to modify the signal, which is known as the Gaussian filter. So Gaussian filter shapes the incoming message signal, and that is why we are getting some modified message signal which is being frequency shift keying, and that is known as the Gaussian minimum shift keying. So in this case, if we look at the signal, that is x of GMSK T, it is the time domain representation of the Gaussian minimum shift keying signal, which is written as a cos omega ct plus k0 multiplied by integration of x bbt convolution ht dt. So ht dt is the transfer function of the Gaussian filter. So this is a wave shaping circuit which changes the baseband signal into the required modification of the signal. That is why we are telling it is a shaped signal. It is not the actual baseband signal, but it has been shaped to modify, shaped to reduce the effect of noise which the signal is facing when it is traveling through the channel. Therefore, simplified signal expression is further written as a cos omega ct plus into cos theta minus a sin omega ct into sin theta. So theta is the amount of phase which is incorporated due to such Gaussian minimum shift keying technique, and omega ct stands for the carrier signal. So therefore, we are getting the mathematical expression for the Gaussian minimum shift keying signal. Now here the difference between the QPSK and GMSK, that is Gaussian minimum shift keying, has been explored, because we already have seen that quadrature phase shift keying is a robust technique, but though quadrature phase shift keying has amplitude fluctuations, that means there is a abrupt phase variation from 90 degree to 180 degree from that is from offset QPSK to non-offset QPSK. That is why we have already discussed that non-offset QPSK has many disadvantages, such as the spurious fluctuations are introduced due to two number of bit abrupt transition, that is 00 to 11 or 01 to 10, are greatly producing side lobes, which are not only harmful for the modulated signal, but it also uh, distributes the message information in the side lobes. So once we suppress the side lobe, uh, there is a uh, suppression of the message. So such non-offset QPSK is not a wise solution. So that is why offset QPSK has been taken. And more than that, if we go for the minimum shift keying, then we are getting the signals are having most of the power concentrated in the major lobe, and here the shaped baseband pulses are utilized for GMSK, where the major lobe has been greatly influenced by the concentration of the power, because here we are seeing the side lobe is reaching to the very small magnitudes. The GMSK signal has a dependency on the receiver thermal noise. This is one of the important point. It is telling that this is produced partly by the received antenna, and mostly by the radio receiver, because receiving antenna is normally receiving uh, different types of signal along with the required signal. So antenna may be modified to incorporate the filtering option, so that whatever is the uh, contaminated signal is received, it could be filtered at the antenna only, and thereafter the IF filter will reduce the noise more. But it may happen that the thermal noise which may be gathering from the receiving antenna, and thereafter in the radio receiver, due to spurious fluctuation of the signal, we are getting more increase in the thermal noise. So therefore GMSK signal has one of the disadvantage, that the receivable thermal noise goes beyond the limit, and that is why we should take the proper care to reduce the thermal noise, which is obvious in case of GMSK signaling. The channel fading is also one of the disadvantage in case of GMSK signaling. In this case, though it is caused by the multipath propagation of the nature of the radio channel, uh, the channel fading has some other reasons, because when the signal traveling through the channel, the magnitude may be degraded. That is why we are not getting sufficient amount of magnitude to be traveling through the channel, and therefore we are telling that the signal is faded away, and it is not possible to recover from the faded signal. So it is normally occurring in case of the distant receiver, if there is no channel repeaters, if there is no presence of repeater, at that time only channel fading occurs more. So therefore we should think about the GMSK signaling, so that precautions may be taken to avoid the channel fading. The band limiting is another criteria. This is mostly associated with the receiver if frequency and phase characteristics of the signal is not properly uh, behaving. So therefore the band limitation is also one of the disadvantage. There is also DC drift may occur. The average value of the signal may have a drift, and that will cause the signal to be more prone to noise. So it may be caused due to the number of factors, such as the temperature variations, asymmetry of the frequency responses of the receiver, frequency drifts of the receiver in local oscillator. Now GMSK modulator has the initial stage of Gaussian low pass filter. It is accepting the data, and it is a Gaussian low pass filter because the nature of the low pass filter is Gaussian. The meaning of Gaussian means It is not the abrupt rise or abrupt fall, but it is a smooth rise or smooth fall. Looks like one half of the sinusoidal wave, that is either positive half or negative half. So here the Gaussian is considered as the positive half of the sinusoidal wave. There is a smooth transition of the rectangular edge, that is positive edge or negative edge of the rectangular pulse has been smoothed out. Therefore, it will be a smooth phase variation. So main purpose of the Gaussian filtering is to smoothing the rectangular data. So whatever data is input to the Gaussian low pass filter, that is rectangular in nature. So once it is fed to the Gaussian low pass filter, the uh, positive edge or negative edge of the binary information is smoothing out, and we are getting the output signal is truly a smooth variation of the output of the Gaussian low pass filter is fed to the voltage control oscillator. In the voltage control oscillator, the equivalent carrier frequency is generated depending on the variation of the phase in the incoming message. So as the message that is fed to the, that is binary data which is fed to the voltage control oscillator, is not the abrupt variation of the magnitude. That means it is not a 0 to 1 or 1 to 0 sharp transition. That is why gradual increase of magnitude or gradual decrease of magnitude may produce the carrier frequency which is gradually shifting from one frequency to another frequency. So therefore, such a voltage controlled oscillator output signal will have many frequencies in the output, and that will not produce any abrupt phase variation, and that is why chances of noise in the output signal will be very less. And finally, the radio frequency amplifier smooth out all the possibility of the noises, and we are getting the signal perfectly amplified at the output. So GMSK modulator produces the required signal through the VCO, and such a signal will be robust in nature in terms of the maximum power concentration in the major lobe, and the minor lobes are having very low power. So therefore GMSK modulated signal is very strong and robust signal for transmission of data through the channel. So GMSK modulator can also be uh, implemented in this circuit. Here the Gaussian low pass filter is again present at the input side, where the data is fed to the Gaussian low pass filter. So therefore we can smooth out the transitions, and this smooth transition binary data will have minimum amount of phase shift. Therefore, when it is passing through the so here the data is that is smooth data is flowing through the two number of paths. At the top path there is no 90 phase shift, but at the bottom path there is 90-degree phase shift. That is why these two paths are called in phase and quadrature channel, because both are orthogonal to each other. These are such that because the carrier signal fed to the multiplier are also orthogonal in nature. At the top side, normally cosine signals are fed, and at the bottom side, 90-degree phase shift allowed to make a 90-degree phase shift allowed to produce some quadrature effect of the carrier signal, and thereafter the product of the multiplier, that is multiplier produces the product that is fed to the summer, and in this way we are also able to produce the GMSK signal. So that is why it is known as the in-phase and quadrature signal, and this is the spectral density of the GMSK signal. The GMSK signal is having more concentrated power in the major lobe compared to the minimum shifting signal. That is why it has the modulation signal more robust compared to minimum shifting. We already have seen in case of minimum shift keying, the care has been taken to avoid the abrupt transition of the binary data, which was happening in case of quadrature phase shift keying. But in case of GMSK, we have seen it has been removed. So therefore, those precautions has been taken, and further Gaussian minimum shift keying has taken more precautions. That is why we are getting the power which is concentrated in the major node is more compared to the minimum shift keying. That is why GMSK signals are preferred, but still GMSK signals are having some limitations. That is why we need more precautions to be applied to the GMSK signals produced in terms of the device temperature, in terms of the uh, uh, intersymbol interference. So here in the x-axis, frequency per unit bitrate offset from carrier, and in the y-axis it is the relative signal amplitude in decibel plotted. So GMSK spectral density with offset of from carrier has been shown here, and it is a comparison of GMSK signal with reference to the minimum shift keying signal. Thank you.